Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we're going to talk about finding the right balance of energy resources to fuel our modern society. My guest today is Dr. Jalal Torabzadeh. Dr. Torabzadeh is the Department Chair of Mechanical and Aerospace Engineering. Welcome, Jalal, and thank you for joining us on Talking Points.
Thank you, Dave, for having me here. It's a great pleasure to be part of the show.
Well, we're glad to have you. And so let's go ahead and get started on our topic. And that's, again, finding the right balance of resources, because we know that it takes a lot of energy, a lot of abundant and reliable sources of energy in order to fuel our society. And it's very complex. The conversation in the last 10 or 15 years has definitely turned dramatically toward renewable energy and sources of green energy, and those which are not generating carbon dioxide and other fossil fuel related emissions. So as we talk about fossil fuels and hydrocarbons and so forth, I think we should start the conversation by going way back and following it very briefly to the future in terms of how we utilized hydrocarbons in the first place. Well, our earliest ancestors realized that fire was the best way to cook their food, to light their caves or wherever they were dwelling, and also to light the night sky. And then eventually they learned to use fire to forge metals and create alloys like bronze. And then eventually we got into coal and steam and heating water to create steam to fuel our factories and our transportation systems. And then, of course, petroleum, which we've had for more than 100 years. And so the bottom line is combustion, which is burning things and changing the state of matter from either a liquid or a solid to a vaporific state or a gaseous state, releases a lot of energy. And why is it that combustion has been such an effective tool for releasing abundant energy?
Thank you, Dave, for pointing out to the importance of having any form of energy for sustainability of life on Earth. As you indicated, energy is the driving force of the whole world. And so as you indicated, they started with the primitive human beings started with burning wood or vegetations, whatever they could in order to keep themselves warm, make food, and later on, make tools and other things. And then they moved to others when, for example, coal was discovered and started almost the Industrial Revolution and made those happen. The energy sources that we had experience over the years mainly involves a material that combusts. And combustion is a chemical reaction, basically, that takes place between a material that can generate fuel, can generate energy by burning with air. Oxygen is the main component of any combustion process. So as a result of that, it causes environmental issues, obviously. And fossil fuels in particular, as we know, they have carbons. Starting with coal, which it can be considered as pure carbon. When combusted, it produces carbon dioxide, CO2, if it is complete, which is an inert gas, not harmful. But if the combustion is not complete, the part of carbon will be converted to carbon monoxide, which is very toxic. And therefore, there should be, any combustion should be controlled in a way that not produces harmful effect. So the effort over the past decades have been to minimize the issues related to environmental damage that's caused by fossil fuels. Obviously, there are different types of fuel. If I want to go through that, you mentioned about the solid, liquid, and gaseous form of it. Crude oil, when it's underground, consists of literally hundreds of different types of hydrocarbon. And hydrocarbon consists of hydrogen and carbon. So both of them are combustible, and when react with oxygen, they produce energy. So that's why hydrocarbon fuels have been a main source of energy for over a century. So in order to get the highest energy from each material, we need to look at the energy density or the energy content of it. The heavier the molecules of the hydrocarbon, the higher the energy content of it.
I want to step in just a moment and follow up on that with natural gas. Natural gas is already in a gaseous state, and yet it's also very dense with energy. Why is petroleum particularly dense? Is it because of the large hydrocarbon molecules you're describing?
Exactly. As I mentioned, hydrocarbon consists of carbon and hydrogen atoms, and both of these atoms are a source of energy production. So when carbon itself burns, generates energy, and when it's with hydrogen, the hydrogen contributes to the production of energy, because hydrogen is converted to water, carbon is converted to CO2, and for the complete combustion. So the heavier the molecules of the hydrocarbon, the higher the content of the energy in it. So natural gas is mainly the light components of hydrocarbons that exist in a reservoir, mainly methane, ethane, and propane. Most natural gases consist about 80% methane, and that's the cleanest type of hydrocarbon that can be used as a fuel. Although it may not create the amount of energy needed for certain application. For example, for a diesel truck that runs on heavy duty type, we need a diesel fuel, which is much heavier in terms of molecules as well as the energy content of it. So in terms of in the orders, the heavier the molecules, the higher the energy content of it, and the more pollutant in terms of the environment, because there are impurities associated with that. Petroleum is not a pure substance. It's a mixture of many hydrocarbons plus additional components such as sulfur, nitrogen, that when burns, that creates nitrous oxides, sulfur oxide, and those are harmful as well. So for example, in gasoline, we try to minimize the NOx formation and as well as other, even in natural gas burning trucks or household application, energy of the energy that's produced should be clean. So just to go back to your answer to your question is that natural gas has been the cleanest form of hydrocarbon fuel, but it may not be good for all the application. And we have to have different types of fuel based on the energy needs of a particular device that we want to operate. For example, in a car, the best one was gasoline, which is a much heavier components of hydrocarbon. Diesel is even heavier than gasoline.
So it seems to me that there are actually a couple of reasons why we've chosen petroleum products to be the main source of our fuel for the last more than 100 years. It's because they are so rich in energy density, and they're also available and plentiful. And we've developed all these techniques to be able to extract oil and petroleum from the ground. I want to move to another topic related to oil, and that is the peak oil phenomenon that was discussed a number of years ago. I think you're going to tell me it started in the 1960s, the thinking about peak oil. Well, about 20 years ago, it reached 20, maybe 25, 30 years ago, it reached a fever pitch where people were saying, well, we're going to run out of oil eventually. It'll be slowly, but over time, but it will lead to a dramatic economic collapse. Well, that hasn't happened, and the peak oil people were wrong. So why were the peak oil proponents wrong? And why have we been able to utilize technologies that allow us to continue using oil?
The peak oil theory, as you mentioned, was introduced in mid-1950s or early 60s by King Hobart. And at that time, he used the available data in terms of the volume of the oils, the reserves that at that time they know it, and the technology that was available at that time to predict the maximum production of oil when the peak, when the production is going to decline. And the theory worked based on the information that he had at that time, up to early 70s. But later on, with the new technologies that were developed in terms of recovering oil, and the definition of reserve was changed basically to include, probable reserves. That means when we define a reserve, it depends on how much of it we can recover versus what is there in underground. And when we are talking about an oil reservoir, the oils or gas are in the porous space of the rock, and they are not like a free pool of oil or gas that we drill and bring it. They are in the porous material, the sedimentary rocks. So, in addition to oil and gas, there are water in there, in the porous space that are connected. We have to push them to move from one place to another. And even with all the technologies that's developed, the primary recovery, secondary recovery, part of the oil remains under that which is called residual oil. And at that time, they predicted that, for example, the residual oil that remains is 70% or 60%, but with the technologies that were developed later on, they could bring more oil out of the ground. And even with the highest technology that we have right now, more than 50% of the oil that have been discovered are still underground, that cannot be recovered with the current technology. The additional technology, which is called enhanced oil recovery methods, and all these things are very expensive. Where they were developed, the technologies were developed in 80s and 90s, but have not been used. So the theory of the peak oil did not last because lack of knowledge on how much oil and gas we had. They did not consider the new discoveries or probable discoveries that could happen, as well as the distribution and of the oil and how we can maximize the production.
Well, on that note, we do have to go to the break. When we come back from the break, we'll be discussing nuclear power, as well as renewable energy and what the promises are from renewable energy. Stay tuned.
I don't remember how it started. Our back and forth. Victory. Fumble. Repeat. It always came back.
Dad!
Okay, here we go, throw it!
Yeah.
You probably don't remember what you told me,
That was perfect.
but I heard every word.
Nice.
Welcome back to Talking Points. I'm Dave Kelly, and my guest today is Dr. Jalal Torabzadeh. Jalal, when we went to the break, I promised that we would talk about nuclear power. We'll talk about that in just a moment. But first, I want to finish up with oil and petroleum. We talked about peak oil and how the predictions that we would run out of oil were wrong. and we still have plenty of oil. The question is, how much oil do we have? I'm talking about the global supply,
Yes.
and then also specific to the United States and Canada. How much do we have here? How long will it last?
As I mentioned earlier, depending on how we define reserves, the amount that are predicted is different. So in oil and gas industry, there are two definitions of reserve. One is called proven reserve or proved reserve, which means the amount of oil that can be recovered with the current technology economically. So, and that's subject to change because based on the economy, a reserve that was, let's say, 100 barrels 10 years ago, now it becomes 150 barrels because there are no new technology that can develop that, as well as the economic considerations of this. And there is probable reserves, which is based on estimates from geologists and petroleum engineers, that they look at the data from reservoir and estimate that this is the amount of oil that exists in this or gas that exists in that. So these numbers that you see in the papers and are depending on who is recording that and where is it coming. From my source of information, which is U.S. Energy Information Agency, as well as the Oil and Gas Journal, as of now, the world reserve is around 2.1 trillion barrels of oil recoverable. U.S. has about 50 to 60 billion barrels of that. So it's about 4 or 5% of that. Canada has about 10% of that oil reserve. So together, U.S. and Canada has about 15% of the oil reserves. At the global level, when we look at it, the oil production right now is about 100 million barrels per day. 30% is coming from OPEC countries, and the others are from non-OPEC countries, including U.S. U.S. was the importer of oil, as you remember, in 70s, and now U.S. is almost balanced in terms of the production and consumption of oil. In the U.S., we consume about 20 million barrels per day of crude oil and petroleum liquid product, basically. So, but U.S. produces about 12 million barrels of oil per day and about 8 million barrels of what we call it condensate, the liquids that can be, is very similar to oil, but lighter and can be produced. So in the past few years, U.S. has been exporting products to many countries. In terms of we are still importing from about 8 million barrels of it, but equally we export about 8 million barrels of hydrocarbon products, like gasoline, like jet fuels, and others to other countries. The differences between the reservoirs in the US and Canada are basically the type of the oil that exists. Canada's oil reserves are mostly in tar sands, heavier oils, which are harder to recover. That's why they have higher reserves, but better technologies are needed to extract those. While in the Middle East, the oil is light oil, and it's easier to recover, less costly in terms of that. So when we look at it, U.S. is producing and consuming about 20% of the oil that's at the global level, so equally. So in terms of the time, if we use the number for production versus the consumption and the reserve, we have at least for 50, 60 more years of oil and gas production with the current technology.
All right, and so
Just-
we have plenty of time for
Yeah.
a transition if we're going to make a full transition. But I want to
Yes.
move to nuclear power right now. Nuclear power would seem to check off most of the boxes in terms of not adding to climate change, because you don't generate the hydrocarbon exhaust emissions from nuclear power. It's a clean energy, and it's very energy dense, and it's very efficient, and so on. Of course, there are concerns about nuclear power. If you have an earthquake or a tsunami, it can release radioactive particles or gases, which is not a good thing. Also, there is the possibility of meltdowns and things of that nature. But why has nuclear power lost favor with people that don't want us to use fossil fuels?
When we talk about nuclear energy, we are talking totally different things. As you mentioned, the main mechanism for hydrocarbon fuels or fossil fuel is combustion and burning it and producing, emissions that are not desirable. Energy generation from nuclear materials is based on fusion and the nuclear reaction that takes place. So it has no byproducts that are undesirable in terms of environmental concern. So the many advantages of our clean energy, and it's mostly for production of electricity, as has been used in many countries, and still some countries like France that's been their main source of energy production, and many other European countries are doing that. But as you mentioned, the safety consideration. The event that happens with, 3 Mile Islands and Chernobyl, are good indications of how dangerous this type of, reactors could be if they go wrong. But with the current technology and development, there would be definitely safer operation of this, as many countries have done it. And in the U.S., I think those events, the 3 Mile Island and a few other incidents around the world, or what happened in Japan, a few years ago, discourage many countries or government agencies about building or adding more nuclear, energy production system. But it may change, again, depending on the competition between, having a reliable source of energy and the keeping the environment clean. It may change. And some countries are going back to that. Still, in the U.S., over 20% of electricity is generated from nuclear power plants.
So it's still with us, but we need to move along. Sure. Just in the interest of time. Yeah. Let's talk about renewables. The ones that get the most attention today seem to be solar and wind, yes. But we also have geothermal, hydroelectric, and even wave energy on the coasts to harness that wave energy. What are the possibilities for renewable energy, and what are some of the drawbacks or some of the limitations that come with renewable energy?
We are at the time that we have to think about energy transition. There's no doubt about it. So whether we run out of oil or gas or other issues, we have to have alternatives. And again, depending on the applications and the locations, countries that are needed, the priorities are different. In the industrialized world, obviously, environmental issues becoming more significant in terms of policy making. So we have no choice to move in that direction. As you mentioned, there are several options. So it's a matter of technology and cost and the economic consideration and other public policies that governs this. Solar is the cleanest and the most reliable and abundant source of energy. So the sun. So anything that's invested in that is going to go a long way. While energy from, for example, wave depends on the conditions. certain areas that's not possible. If you want to use waves at ocean level versus a lake level, that are totally different way of doing it. Geothermal energy has been used for many years in many countries, like New Zealand and Australia and some parts of Europe. That's also clean. It's the energy that's stored in the earth, the hot water and hot gases, which is mainly water, vapor, that can be used as a source of energy conversion. So those are great sources, but it's going to be gradual. The percentage of energy contribution from geothermal in this country has not been a lot, but there is now a renewed effort in that respect. More effort has been put on solar. But again, reliability on that. There are certain areas that solar cannot be good. So when we look at the renewable energy, we need to look at the conditions that we have and at a local or country level, or even, for example, in the US, a state can have different policies on renewable energies.
I'm going to have to cut in right now. We're running out of time. We only have about a minute and a half left.
I'm sorry.
And so I want to combine the last two questions and give you a chance to answer that. And those questions are, what are the technologies that you think hold the most promise in the near term and in the moderate term in terms of technology development? And what is the most important consideration as we think about all of these issues we discussed today?
As we see, having abundant and reliable energy is a must for the society to move on. So we have to think about the transition from fossil fuel to renewable. That's going to take decades. It's not going to be overnight. It took us more than 100 years to be addicted to oil and gas. And now to move in that direction, it is imperative that we have to put our efforts at all levels in terms of research, development, R&D, as well as applications that can be done. The challenges that I see right now, the first thing is to keep our environment clean from what we have already contributed in terms of emissions and specifically carbon dioxide. Carbon dioxide is a major issue. Carbon sequestration is a fact, and many institutions, universities, research centers are developing new techniques. Development of new technology for generation of hydrogen, for example, as a fuel is important. And also minimizing the side effects of all these alternative or energy sources are the big challenge or the great challenges for the society now.
And on that note, we have run out of time, but I want to thank you for being here today.
Well, thank you very much, and thank you for having me here. It was a great pleasure.
And join us again for the next episode of Talking Points. Until then, I'm Dave Kelly. Have a nice day.